Hello friends, a few weeks ago on March 14th, 2024, the Figma team released a very well-written technical article explaining how they scaled Postgres horizontally. And what's interesting in this article personally for me, and should be interesting for many of you I guess, is that the team decided to create their own sharding solution from scratch. And in this video I want to understand why the team decided to reinvent the wheel, because those of us who are familiar with the Postgres ecosystem, we know that there are so many options that make Postgres scalable and distributed. So let's do a deep dive. Alright, I do understand that not everyone had time to read this article. That's why let me do a quick introduction for all of us. Scrolling down to the solution overview, it's over here. Historically, the Figma team has already used the vertical partitioning approach. And with this approach, you can take some tables and deploy those tables to dedicated database service. And in these examples, you can see that they took the user table and auth table, and those tables were available on one database server, while the remaining tables, such as files and images, were stored on another database instance. However, this approach works to a certain extent. At some point, you can easily run out of storage space, memory, and compute resources, and this is exactly what happened to the Figma team. That's why they switched to the horizontal sharding approach. On this picture, taking the user table as an example, you can split it into shards. Let's say shards from 1 through 100 will be stored on one database server, and the remaining shards will be located on the other database server. Then if you need to split those servers, you basically move, let's say, shards from 100 to 50 to one database server and the remaining shards to the other servers. But you know what, my friend? This part is the most straightforward one in the overall solution. It's not that difficult to come up with the hash function and then map your original data to shards and distribute those shards to database servers. What's truly challenging is coming next, and the Figma team acknowledged this. Once you have your data distributed across multiple database servers, you need to decide on several things. First, are you going to provide global data integrity? Are you going to support global foreign keys and other types of indexes? Or are you going to give this up? Also, do you support distributed transactions? Because it can happen then. A transaction updates data stored on one database server and another, and someone needs to coordinate this update, and someone needs to roll back changes if the update succeeds on one server but fails on the other one. Also, how do you deal with schema changes? How do you roll out schema changes atomically across all of your shards? And lastly, let's not forget about the developer experience. Should this solution be a black box for developer, or should they get used to this, introducing some of their application level changes? Obviously, the Figma team had to make choices, and they did not address all of the listed challenges. However, their implementation looks as follows. For the sharding approach, they introduced the concept of colors, so data collocation. It's when you have some related data stored together. Let's say you have the user table, and the user table is already sharded. And then every user has some data stored in the favorites table. Let's say my record of Figma is stored on this database instance, and all of my favorites are also stored on the same database instance. And then you can use the same for the files. Every file has a list of comments, and the comments of a specific file are always grouped and stored together. This makes total sense because that would allow you to execute efficient joins, minimizing the data movement over the network. Also, they did not want the application to be responsible for the routing of the requests. That's why they created this DB proxy component. The application connects to this DB proxy component, and that component decides what shard, what database node needs to execute a specific application request. In this example, you can take a look how this works in practice. If it's possible for the DB proxy to get a specific shard in database instance for the request will be routed to this shard number 4, as in this example. But sometimes the sharding key might not be specified, and which would require the DB proxy to execute this request over all of the database nodes. So this is the high-level overview of the sharding solution that was created by the Figma team internally. Now, $1 million question, my friend. Why would the knowledgeable and experienced Figma team decide to reinvent the wheel and create the custom solution for sharding? Let's scroll to the top, and here is, unique approach. Speaking about this unique approach, honestly, it doesn't look unique to me, because this is exactly what I personally did 15 years ago. 15 years ago, I worked on a project where we had to shard Postgres across multiple database servers. And we also did this manually. We also used the concept of collocation. We stored data together, and we also had a component that is similar to DB proxy. But that was 15 years ago. Those days, the Citus extension of Postgres, Yuga by DB, and other solutions of the Postgres ecosystem that make it distributed, they did not exist. These days, the situation is different. So let's see how the Figma team explains what they did. First, they acknowledge that they evaluated several solutions that can make Postgres horizontally scalable and distributed. And also, I guess, as a backup plan, they did the same for MySQL. Specifically, during the evaluation, they took a look at CockroachDB, TIDB, Spanner, and Vitess. However, they did not switch to any of these options, and it's not about technical limitations in those databases. They stated that switching to any of these alternative databases would have required a complex data migration to ensure consistency and reliability. Plus, they highlighted that given our very aggressive growth rate, we had only a month of runaway remaining. They were running out of storage and probably compute capacity that was given by the largest Amazon instances. So generally speaking, they had a time pressure, and they did not want to take risk of migrating from Postgres to a distributed database instance. And that's what was the reason, the primary reason. However, my thinking is that this is the tip of the iceberg, and there is something else. If you continue reading this article carefully, you will notice the Figma team saying that we have developed a lot of expertise on how to reliably and performantly run RDS Postgres in-house. While migrating, we would have had to rebuild our domain expertise from scratch. So the key message here is RDS Postgres. The Figma team does not use Postgres open source in the cloud. Instead, they're consuming it as a service from Amazon. RDS is a fully managed service offering for Postgres. And the thing about RDS and other managed service offerings by other big cloud providers is that you will certainly get access to the core database capabilities, but you might not get a full support for all of the extensions. And Postgres, if you know Postgres really well, Postgres is about extensions as well. It has a very rich ecosystem of extensions. One of those extensions is Citus, and this became the default go-to option for those who want to make Postgres sharded and horizontally scalable. But the problem is, if you go to Amazon extensions list, Amazon RDS, you will not find Citus in this list. So generally speaking, Amazon decided not to support Citus, and Figma wanted to continue consuming RDS, and eventually they decided to build their own solution from scratch. Now let's jump back to the article, to the closing section, where the Figma team talks about the future. Because there is some speculation on the internet. Some folks say that the Figma might have make this solution mature enough and make it available to everyone. The others say that no, it's highly likely that they will switch to something from the Postgres ecosystem because it takes a lot of time and effort to address a lot of this limitation that their solution has right now. Like they do not support global unique regeneration, there is no support for atomic cross-shard transactions, no any support for distributed global indexes, and the resharding of the data is not fully automated. A lot of things to do. And what I like about the Figma team is that they are very transparent. So as in the beginning they stated that they had a lack of time, at least right now with the current solution, they have bought themselves sufficient runway. They have bandwidth to re-evaluate the trade-offs of continuing down our current path with the current solution versus switching to an open source or managed solution. Alright, what are the other options, my friend, that the Figma team might want to use in the future? My thinking is as follows. If the team decides to stick to RDS, then they might become a customer of Amazon Aurora Limitless. This is a new managed service offering by Amazon. It's available in the preview mode right now, and only a selected group of customers can give it a try. Amazon Aurora Limitless is basically a sharded version of Aurora, a sharded version of Postgres. They also distribute your data across shards, and they have those transaction routers your application connects to. So it might be a reasonable option for the Figma team, but the Limitless in the name of the service also implies the cost. Many companies who took part in the evaluation of the service stated that the Limitless is not just about the scalability of Amazon Aurora, but it's also about the price. Many stated that your price can go literally through the roof. Next, let's assume another scenario. Imagine that the Figma team decides to migrate off RDS, and then they will be able to use a plenty of other options that exist in the Postgres ecosystem. The last year, I authored the following article, A Guide to Distributed PostgreSQL, that gives you various options for making your Postgres scalable and distributed. I'm not going to spend time covering them right now because I have already recorded a detailed video on this topic. Once you finish watching this video, just continue watching this guide to get more insights. But as a quick overview on what's covered in this video, we are going to discuss a multi-master asynchronous replication approach. In this approach, you deploy multiple instances of Postgres in several zones or data centers, and then your application can read and write from all of those instances in parallel. And then you use asynchronous replication to make sure that the changes are synchronized across the database instances. With this approach, the primary instances by design scale vertically, and this will not work for the Figma team, which means that they might want to consider another options. One of them is multi-master sharded PostgreSQL with coordinator, and this is basically the sharding solution. One of the most well-known one that I have already mentioned several times is Citus Data, and architecturally it looks similar to what the Figma team has already implemented. You split your database into shards and you deploy multiple database instances, and every instance stores a subset of your data. And then you have your coordinator. The application is connected to coordinator, and coordinator executes the request across those shards. But also Citus implemented and addressed a lot of the limitations that are right now on the list of the Figma's custom solution. And another solution that also is very reasonable for the Figma team is multi-master shared nothing Postgres. In this case, I'm talking about YugaByDB, and YugaByDB is a distributed PostgreSQL. This is a distributed database that is built on Postgres, and in this configuration, you just deploy a multi-node database cluster that is Postgres, and then your application connects to any of these nodes and executes requests. This solution supports distributed transactions, joins, it automatically reshards your data, etc., etc. So these are the different options that exist on the Postgres ecosystem, and the Figma team might use one of them. All right, my friends, hope you like this video and keep mastering databases.